So now that you've done lots of practice at graphing systems to find the solution, let's have a look at a couple of other ways. Sometimes graphing might not be the best option. So there are a couple of ways that we can solve linear systems algebraically. The first one is called substitution. It says this strategy can be used when one equation can be solved for one of the variables and then used as the value in the second equation. So basically you simplify or you rearrange one of the equations and then put it or part of it into the other equation. So let's have a look at the example. Example 1. Solve this system without graphing. 2x plus y is equal to 3 and 4x plus 3y is equal to 5. So you choose one of the two equations and you rewrite it so that you isolate one variable. So in the bubble it says choose an equation to solve for one of the variables. In equation 1, the variable y has a coefficient of 1, so to solve for that equation for y, hint, choose the one that looks easier to rearrange. So if you have to do this, then it's easier to choose the one that looks simpler to rearrange. So because this y value here, this y has a coefficient of 1, it's easy to rearrange this equation. So the first step is I take that equation, 2x plus y is equal to 3. So I've taken this equation and I want to rearrange and isolate for y. So that means I'm going to subtract 2x here. And because I do it on this side of the equal sign, I do it on the other side of the equal sign. That is going to give me y, because these will cancel, is equal to minus 2x. Actually, you know what? I'm just going to leave it this way. 3 minus 2x. So y is equal to this. So then our second step, it says down below, use this value for y and substitute into the other equation, okay? And then you'll end up with an equation in one variable. So essentially what that says is that we're now going to take this thing that we have solved for y. So we know that y is equal to this. Well, if y is equal to this, then I can put it in here for y. Just like we would say, well, if y is equal to 0, I can substitute that in and find x. So that's exactly what we're doing, except in this case, y is equal to a small expression. So down here I go, well, I take my second equation, which was 4x plus 3y is equal to 5, and I'm going to substitute this thing, 3 minus 2x, in for y. So that looks like this, 4x plus 3 times 3 minus 2x, because that's what we solved for y, is equal to 5. Now algebraically, I have an equation with one variable, x, that's it. That means I can solve for that variable. But before I solve for that variable, I have to do some simplification, some rearranging and simplifying. So the first step is I need to get rid of this bracket. I'm going to bomb in this 3. It's going to give me 4x plus 9 minus 6x is equal to 5. Combine my like terms. It's going to give me minus 2x plus 9 is equal to 5. I want to solve for that x, so I'm going to not plus. I'm going to subtract 9, these will cancel. Gives me 2x is equal to 5 minus 9 is negative 4. Divide by negative 2, divide by negative 2. Those will cancel. X is equal to negative 2. So I've solved for negative 2. Oh no, sorry, not negative 2. Negative divided by negative is positive. So x is equal to positive 2. So now that I've found a value for x, I take this value for x and I put it into either one of the two equations. Doesn't matter which one, and find y. So, and maybe I'll do both for you just to show you. If I take that value of x, of 2, and I put it into my first equation, which is 2x plus y is equal to 3, I'm going to substitute in x, that's 2 plus y is equal to 3. 4 plus y is equal to 3. Subtract 4, y is equal to negative 1. If I put it into the other equation, which is 4x, I'll do a different color, 4x plus 3y is equal to 5. If I put in x of 2, oops, that's going to give me 4 times 2 plus 3y is equal to 5. It's going to give me 8 plus 3y is equal to 5. I'm going to subtract 8, subtract 8. That's going to give me 3y is equal to negative 3. Divide by 3, divide by 3. Y is equal to negative 1. Lo and behold, I get the same value, negative 1. So it doesn't matter which equation you choose, you can solve for that missing 1 value using either one of the two. So now I've said, well, I've done all my algebraic work, and I say that x is equal to 2 and y is equal to 1. That's going to be the solution to my system. 2, sorry, I think I said 1, I meant negative 1. 2, negative 1. So now, just to make sure, I need to verify. Okay? So I take that equation, or take that system solution, and I put it first into one equation, 2x plus y is equal to 3, which would be 2 times 2 plus 1 is equal to 3, sorry, plus negative 1, which is 4 plus negative 1 equals 3, which is 3 equals 3, which is correct. And I also do the same thing for my other equation. 4x plus 3y is equal to 5. 4 times 2 plus 3 times negative 1 is equal to 5. 8 minus 3 is equal to 5. 5 is equal to 5. And that is correct. So I've taken my two equations, I've rearranged one to isolate a variable, substitute what's left into the other equation, and solved for the missing value. Taken that missing value, put it into one of the other equations to find the other value, and it depends on what you're working with, x or y, to give me an xy coordinate of a solution to the system. Verify the system or the solution by substituting back into each equation. Okay. The next question is a practice question. Give it a whirl and see how well you do. When we come back, or when I come back, I will have the solution for you.